Okay, good morning to everyone. My name is Conchi Muñoz Díez, and I am the coordinator of GEN4OLIVE, an European project dedicated to olive pre-breeding activities. It's my pleasure to welcome you to this webinar, and I sincerely thank you for joining us today. In this session, we will present two key outcomes of our project that we believe will make a significant impact on the olive sector. First, the GEN4OLIVE database, a comprehensive resource compiling information of more than 600 olive cultivars from five participating germplasm banks. This database includes images, agronomic characterizations, and evaluations of biotic and abiotic stresses. Second, we will present two innovative applications which allow users to identify olive cultivars and pests and diseases affecting this crop simply by using pictures. We believe that the development and the public availability of these tools mark a major milestone for the olive sector, benefiting farmers, breeders, and researchers. I hope that by the end of this presentation, you will also share our enthusiasm. To provide further insights into the development of this database and the application, I would like to introduce Professor Luigi Mancini from the Computer Science Department at the University of La Sapienza in Rome, who led the team behind these innovations. So, Professor Mancini, the floor is yours.
Thank you. Thank you very much for the introduction. Good morning to everybody. Welcome to this demo day of the GEN4OLIVE projects. We are thrilled to have you with us today as we showcase the capability of our web platform and the machine learning tools developed throughout the project. Before I hand over the floor to my fantastic team, by the way, I would take the opportunity to thank my team for their hard work and dedication for this project. I would like to take a few moments to provide some context on the broader potential of these IT tools that we have developed both in the olive industry and in agriculture as a whole. I will keep my introduction very brief as time is limited and we have many things to present. However, all the slides containing the full details of our presentation will be shared with all participants. And if you are interested in exploring the innovative aspect of our proposal further, please feel free to reach out to me. Perhaps, Alicia, you could show some of the slides that are related of the impact of this project while I'm talking over it. So let us start with our GEN4OLIVE web platform. So this platform represents, to me, from my point of view, represents a significant advancement in agricultural research and practice, and also within the olive sector. By what we do, we integrate databases and research results from multiple institutions which are partners of this project. By doing that, the GEN4OLIVE web platform creates a dynamic, accessible space for scholars and professionals to explore and cross-reference information about hundreds of olive varieties across the Mediterranean countries. Unlike traditional data repository, this system offers interactive consultation, allowing users to receive tailored insight that enhance their understanding of key areas, such as botany, olive growing, and agrometeorology, and so on. The inclusion of images and technical specification in GEN4OLIVE web platform further enriches value with free access via web interface and smartphone apps. This tool facilitates better decision-making in research and industry while fostering innovation in olive cultivation and management. So in addition to the web platform, perhaps you can go to the next slide, we are developing two cutting-edge machine learning tools during the GEN4OLIVE project. One designed for identifying olive varieties and another focus on detecting diseases that affect olive trees. These tools are powered by the latest advancement in machine learning technology and the deep neural network. And I believe they are the potential for revolutionize both the olive sector and broader agriculture practice. The variety identification tools makes varietal identification faster, more accessible, and cost-effective. The AI-driven tools can aid in breeding programs, ensure product authenticity, and support sustainable cultivation practice. Beyond olives, similar AI models could be adapted for other crops, improving traceability and decision-making in the agricultural supply chain. The AI-driven tool, the other tool, the latest tool, the one for detecting disease, perhaps we can go to the next slide, Alicia. Affect olive tree. This second AI-driven tool detects diseases that affect olive trees. And this tool can identify symptoms at an early stage, allowing farmers to take timely action and reduce the spread of diseases. Overall, I believe that our GEN4OLIVE web platform and the AI tools are not just IT tools for today, but a resource for further advancement in the industry and agriculture. So I'm finished with my presentation. I would just want to say that the presentation will be recorded, and both the slides and the recording will be available to everybody participating online. With that, I will hand it over to my team to dive into the technical details of this exciting innovation. Thank you very much for joining us.
Thank you very much for the introduction. So good morning, everyone, and thank you for joining us on this 2-hour training that is related to the tools that we developed during this project. I am Alicia K. Bidi. I'm an innovation specialist from Sapienza University of Rome, and I will be very happy to be your host today. I would like to start by thanking you for showing interest in our work and also for being here with us today. So we are really proud of what we have achieved during this project, so we are pretty enthusiastic to share our results with you. Before we start, a couple of important pieces of information. So as Professor Mancini mentioned, this presentation will be recorded and you will have access to the recording after the presentation online. We also encourage you to enable the option that is called closed caption by following the instructions that you can see on this slide. So on the bottom left, you can see that there is a CC icon. Just click on it. By doing that, you will not only hear me present, but you will also see written the text that I am saying. Once you have done it, if you want this text to be displayed instead of the chat, you just need to click on the icon with the bubble on the section 2 of this slide. So first click the CC close to number 1, and then if you want the text to appear in the chat, just click on number 2. So let us begin. Let us start with a short introduction. So as mentioned previously, I am Alicia K. Bidi, I'm your host, and I'm an innovation specialist that is working for Sapienza University of Rome. And today I'll be assisted by Professor Munoz-Diaz, who is our project coordinator, Professor Mancini, who is our team leader here at Sapienza, Professor Itai, who is in charge of leading the creation of the website, the application, and the machine learning tools, and Professor Miho, who is our project manager for the whole project. So Professor Mancini and Professor Itai will be our artificial intelligence experts, and they can answer any technical question that you might have. And Professor Munoz-Diaz and Miho will be our agronomy expert, and they can help with any question that is related to agronomy. I know that sometimes I'm speaking fast, so if during the presentation I'm going too fast, just feel free to let me know and I will slow down. So during this session, you will be learning different things. You're going to learn how to use the platforms from the GEN4OLIVE project. And more specifically, at the end of the training session, you will be able to first navigate the GEN4OLIVE platforms. That is to say that you will be able to efficiently access and explore the olive variety database for research and selection. You will also gain a basic high-level understanding on the AI technology that is behind the platform. So in other words, I will explain to you how the system processes data. Then you will learn how to use the machine learning tools to identify olive varieties and detect diseases from images. And finally, I will explain to you how to interpret the results that you will get from these tools. So this is our agenda for today. We might spend some more time on some sections based on questions and interest, but this gives you an idea of what we will be covering. First, we will go through a short introduction. I will give you an overview of the GEN4OLIVE project, really high level. Then we will explore the olive variety database and the advanced filtering functionality. In this section, I will explain to you how to get the best out of this tool. After that, we will explore the machine learning tools that are used for variety and disease identification. And then we will proceed with a real-time demo in which I will give you some use cases and I will show you how to navigate the website and the application. And finally, we will answer any question that you might have and conclude the meeting. So throughout this presentation, you will be able to ask questions by using the link that you can see on this slide. Feel free to scan the QR code now and leave the page open. You can ask questions whenever you want, even while I'm talking, and I will answer them at the end of each section. Now, remember that there is no stupid question. We are here to help you understand how the tools work. So if you do not understand something, I can go over the content again without problems. If you are not comfortable with English, you can write the questions in your own language. We have members of the consortium that speaks a lot of different languages, so they can help with translating your questions. Now, if you have any problems during the meeting, for example, you cannot see the slides or you do not hear me, please feel free to raise your hand as shown on this screenshot. Sorry, I'm losing my voice. Feel free to raise your hand as seen on the screenshot. It's this icon, the small icon with the hand. And we will come back to you to see what the problem is. So let us start with a quick overview of the GEN4OLIVE project. So GEN4OLIVE is a project that was founded by the European Union as part of the Horizon 2020 program. The topic is related to genetic resources and pre-breeding communities. It has a duration of 4 years and it has an overall budget of 7.5 million euros. The University of Córdoba from Spain is the coordinator of the project. GEN4OLIVE gathers 16 partners from 7 countries, as well as 5 small and medium enterprises. There are also 5 of the most representative olive germplasm banks that are participating. So out of the germplasm banks, 3 are international, Córdoba, Marrakesh, and Izmir, and 2 are complementary banks from Rende, Italy, and Hania in Greece. So as you can see, the project covers most of the olive producing zones in the Mediterranean, and it brings together a wide range of expertise and knowledge from various actors in the industry. So on this slide, you can see the logos of the 16 partners who contributed to this project. So let me add that we are truly grateful to the European Commission for making this project possible, and we're also really grateful, obviously, to our partners for all the efforts that they have made to make this project a success. So to give you a bit of background on the project, I'm going to explain to you why the GEN4OLIVE project was created. The first and the most pressing reason is biodiversity loss. In fact, over 1,200 olive varieties exist, but only 5% of them are widely cultivated. Wild and ancient olives are particularly underutilized, and this limits not only the genetic diversity, but also the resilience of crops in the face of environmental challenges. Another important issue is climate change and diseases. So with rising temperatures, drought, and so on, there are also new pests that are putting olive production at risk. And some regions are already experiencing serious declines in the production of olive oil. Without proper action, these actions can really have severe consequences, and both in terms of economic consequences, but also environmental consequences. When we started the project, there was also an important structural challenge, which is the lack of standardized evaluation protocols. So you see, when researchers are developing new olive varieties, they need to measure and evaluate some genetic traits. The problem is that these protocols are not the same across the board. Different countries are using different methods. So this makes it really hard to compare varieties from different regions and build a reliable scientific foundation for developing the best varieties when we are moving forward. Now, this lack of standardization also led to difficulties in collaboration. If not everyone in the industry, whether they're working in jar plus banks, breeding or farming, is using the same metrics and languages, it makes it hard to understand each other. And it makes it also harder to share knowledge and resources. There are some local initiatives that existed to face this challenge, but they were simply not enough to address the problem. And finally, there is a lack of access to genetic resources. So there's a lot of information about olive genetics, but it's often not accessible or understandable for the people who need it the most. Much of this data is actually stored in GEN banks, which are part of the project, but these banks often struggle to communicate with one another, and this limits innovation and progress in the sector. So the GEN4OLIVE project was created exactly to tackle these challenges. First, we've established standardized evaluation protocols to ensure consistency in how we assess key traits. So these traits include biotic stress, pests, diseases, plant architecture, agronomy, oil quality, and phenology. By aligning our methods across region and collaborating with other R&D projects, we made sure that we were measuring the same traits in the same way. Second, we focused on preserving and characterizing olive biodiversity. We documented a broad collection of cultivated olives. As far as white olives are concerned, we identified and we analyzed their genotypes, and then we selected those with the most valuable traits. For example, low susceptibility to a specific disease. Having done that, we wanted to make these genetic resources easily accessible. So that is why we created a user-friendly database where farmers, breeders, and researchers could quickly find information on olive genetic resources and the varieties that best suit their needs. We also built two powerful AI tools. These machine learning models, they help farmers and researchers accurately identify olive varieties and diagnose diseases, helping them streamline their decision-making. Finally, we enhance accessibility by integrating all these features into a free website and a mobile application that improved access to genetic resources. So this creates a space where GEN+ banks, breeders, farmers, or really any stakeholder in the industry can collaborate and share knowledge, helping drive innovation. So to summarize, this project has really produced practical solutions with the ambition to make the olive sector more sustainable and efficient in the future. In part one of this presentation, I will give you an overview of the two platforms. We will navigate the website and the application, and I will explain what information you can find on the platform and where you can access it. So first, let me focus on the two interfaces that we have created that support the same purpose. So the project led to the creation of two platforms. The first one is a mobile application, and the second one is a website. They both provide access to the same content, but they are tailored for different needs. The website is ideal for in-depth research and data analysis, while the mobile app offers a more practical interface. It's ideal for routine tasks like variety identification and disease detection in controlled environments. So for example, labs, breeding stations, where access to the computer might be more limited. So first, let us go through the extensive database that you can access through the website and the mobile application. This database actually gathers all the scientific results that we have achieved throughout the project, and it will give you access to a large collection of information on olive varieties. I will first list all the data that you will find available on this database, and then I will tell you more about how to filter it. After that, I will share my screen and I will show you how you can access and navigate these sections yourself. So the database is accessible on both the website and the mobile application. You can find it in a section that is called Interactive Database. I will show it to you after. Each olive variety has its own dedicated page with specific information. The first type of information that you will find is the name of the variety and, most importantly, the synonyms. So in fact, there are some varieties that are genetically the same, but they have different names in different countries. On the same page, you will find information on the germ plus banks in which the olive variety can be found and the country of origin of the cultivar. Be careful, because the country of origin is not necessarily the country in which the variety grows. It's the country from which the cultivar is originary. It traces its origin. You will also find high quality pictures on this same page with healthy branches, leaves, whole fruits, and also endocarps, which is the stone inside the fruit. So you can see some examples of pictures that are present on the platform on this slide. For example, a picture of a healthy branch in picture number 1, healthy fruits in picture number 2, and healthy leaves in picture number 3. So now these images are more than just references. They also show important agronomic traits like leaf shape, fruit morphology, stone morphology, which can be particularly useful for researchers and germ plus banks. The second type of information that you're going to find on this platform is information on olive oil yield and quality. These information include fatty acid profile, phenolic profile, volatile green notes related compounds, volatile fruity intensity related compounds, and oil yield. If data is not available for a specific variety, it will be signaled as ND, like you can see here. ND means no data. As explained previously, all this data is the result of extensive scientific research that is represented in a simple way to facilitate its comprehension for the user. You will find varieties ranked from 1 to 5 on a scale, and this allows for comparison between varieties. If you hover the eye, I will show you on my screen right after, but if you hover the eye, you will find the meaning of the scale. So for example, here we can see that we hover the eye for oil yield. So here is represented from a scale of 1 to 5. 1 is low oil content, 5 is high oil content. So we can see that this particular variety, which is Arbequina, has an oil yield of a rating of 3 out of 5. So what does this mean? So the scale was established as follows. We analyzed all the olive varieties on the platform and then we ranked them based on their oil yield. If a variety has a yield of 5 out of 5, it means that it ranks in the top 20% of all the varieties that we have analyzed for oil yield. If it has a rating of 1 out of 5, it means that it's in the bottom 20%. So you can think of it as a comparative scale to compare different olive varieties on different criteria. Next, you can find information on susceptibility to pests and diseases. So this is going to include data on the susceptibility of plants to 6 diseases and pests, including verticillium, Scilla fastidiosa, leaf peacock spot, Cercospora leaf spot, olive anthracnose, and olive fruit fly. Once again, those are represented on a scale from 1 to 5, 1 being low susceptibility and 5 being high susceptibility. So our test variety, for example, is not so susceptible to olive anthracnose, but is highly susceptible to Cercospora. You will also find information on climate adaptability. So in particular, you will find information on frost sensitivity and drought sensitivity. The scale is the same. 1 is low susceptibility, while 5 is high susceptibility. So now this information is quite important because across the Mediterranean, many countries are more than ever subject to drought or fluctuation in temperature. So this information is particularly interesting. Next, you will find information on phenological process evaluation. This includes bud burst time, olive flowering time, and olive ripening time. Once again, scale from 1 to 5. Here we can see that Arbequina has a low, an early flowering time compared to other varieties present on the platform. So this information is essential because it's directly linked to the tree reproductive cycle, which results in fruit production. A disorder in flowering time, for example, can lead to lower oil production. So it is one of the many important factors that farmers and breeders might want to know of. Other data include table olive altitude. This is information that will be more useful to those who need to trade, transport, or simply display olives as part of their work. Once again, represented on a scale from 1 to 5, really simple. Our test variety here, for example, is slightly wider than other varieties. It bruises more easily, and it is symmetric. And finally, the database gives you information on agronomic traits. So those include tree growth habit, tree vigor, tree density, flowering load, fruit detachment resistance, and fruit average weight. This information can be useful to a wide range of stakeholders, but it is particularly useful for breeders and farmers who might have limited field space, for example, or they might want to favor trees with heavier loads. So to summarize this first part, the data present in the library can help farmers, breeders, and stakeholders make more informed decisions when they are selecting varieties that they want to plant or cultivate. With this information, they can choose varieties that best suit their unique circumstances. They can also use this information as a point of reference, for example, if they want to compare the performance of their own trees against others of the same variety. Now, please note that this is preliminary data and we're still checking that all the data is correct before opening the website and the application to the general public. So now, this is a lot of information, right? And users, they might want to cross-reference it. Well, the good news is that this is entirely possible. All the data that I have mentioned in this first section can be filtered and combined on the website, allowing users to find the most suitable matches for their unique specific circumstances. So the advanced search filtering function is accessible on the website in the AI tools section and the interactive olive database section, sorry. And I will now show you how to access and use it. But before I show you, please note that this feature is available only for the website. I mean, you can access it on your phone as a website, but not in the application. This was designed for users who have more time to conduct thorough research, so it's available on the website. So let us go through platform navigation. I will first show you the website. Okay, so first I will show you how to explore the website. The website is available on desktop. Maybe let me increase a bit the size so you see better. Okay, perfect. So this is available on desktop and mobile. It's responsive, so you can browse to the screen size. The website is available in many languages. As you can see here, there is English, Spanish, French, Turkish, Albanian, Greek, Italian, and Arabic. To change the language, you simply have to click on the little flags that you see here. So this is a landing page. On this page, you will find a carousel that is presenting content that you can find on the platform. Scrolling down, you will find more information on the project. The About section that is right here It lists information about the GEN4OLIVE project and its consortium. If you hover each of the logos of the institutions, you will find links to their social media. The AI tool section that you see here, I will present it in the second part of this presentation, so I will not go through them now. However, I will go through the tools that you can find here in the interactive OLIVE database section. Here you will find 3 tools. The first one is OLIVE cultivars database. So this is the collection of all the data that has been gathered throughout the project. This data is based on extensive scientific research, as I said before, and it was provided by the partners in this project. There is no user data there, it's only data from the partners. It is represented as a simple form to facilitate users' comprehension. And here you can search for varieties. So let us say that you want to find a variety that is from Albania. I can click here on origins, since I know that Albania is at the beginning of the alphabet, and it will sort by country of origin. If I want to, I can also search directly here. I want a variety that is originally from Albania. So here I just find several varieties, 6 varieties. Now let us say I want to look for a specific variety, for example, Koroneiki. I simply look for it here, and I am going to find on this page some information about this variety. First, I'm going to have the variety name. If I want the synonyms, I need to go here. So here is the variety name. Here you have all the synonyms for this specific variety. Here you have the germplasm banks in which this variety can be found. And here you have the usability. So Koroneiki is a dual-purpose olivar, which means that it can be used for oil and as table olives. I can click on View Detail, and I will have access to the page that I was describing before, where I find all the information about the variety. So first I find the usability, the synonyms, where in which germplasm bank this variety can be found, if this variety was evaluated as part of the project. Then I will find pictures, which are references. All these pictures have been taken also by the consortium members. So here, for example, I can find pictures of branches with healthy fruits. Here, 3 pictures, and here I can find the fruit, the leaf, the endocarp of a healthy tree, from a healthy tree. So let us say I want information about the yield and quality. I click here, and I will have the information that I showed you on the slides before. Let us say I'm interested in the oil yield. So I don't remember what this scale means. So I'm going to simply hover here, and I'm going to see that 1 is low oil content, 5 is high oil content. And this is the same for all the categories. So yield and quality information, as we said before. Resistance to pests and diseases. So here, all the information about the diseases and pests that we mentioned before. Same, if you want to have information about what the scale means, you hover here. You can also click and it's going to stay visible. So for example, I can open several ones. Climate adaptability information, phenological process information, and so on and so forth. So all the information that we saw before is available here. For each variety, you will have all this information about this on this page. Sorry. The second tool that you will find in this section is the interactive filtering. So it's the second part of what I presented to you, in the second part of the presentation. This is a system of combined filters that is going to help you sort varieties based on your personal criteria. To choose a value, you simply need to drag the 2 dots that you see at the beginning and at the end of this range. Here, you can see, for example, that I am selecting a range from 3 to 5 and here from 1 to 5. So let us make an example, right? Let us see, I want to find a variety that is used only for oil production. I do not want a table cultivar. I do not want a dual purpose cultivar. So I select here oil cultivar. Let us see that I want this variety to be originary from Greece. Now let us say I want it to be less susceptible to olive fly. So I can select here a low susceptibility to olive fly, because we know that this is a big problem for Greek farmers. And let us say I want a higher olive oil yield. So let us see if we find something. So you can see, for example, here that we have some matching varieties for this specific criteria. So let us say I want to know more about any of these varieties. Let us see this one, for example. I can click View Profile, and I will enter the page that I have shown you before with all the information about the cultivar. So the last section that you will find here is the Olive Germplasm Banks section. So here you will find a list of all the germplasm banks who participated in the project with their contact information. If you hover on a specific germplasm banks, you will find information about their website and their socials. You can also click their name and you will have information about the germplasm banks here, as well as all the varieties that you can find in this specific germplasm bank. So now let me show you the application. So as you can see, while the website is pretty complex and gives access to a lot of functionalities, the application has a much simpler interface because it was thought to be for on-the-go use. So the first section is olive varieties. In this section, you will find the whole library that we saw on the website with all the varieties that were present on the pages I showed you. So we had reached this part of the presentation. We navigated the website and the application. I will show you some more examples after. So if you did not understand something, please let me know and I can make other examples. So let us take some questions now. If you have questions about the machine learning and recognizer tools, please keep them in mind. We'll explore those in the next sections. And something important to mention is the final version of the website and the application. They should be available at the end of March when the project ends. So let us have a look at questions. So the first question is, does this application work in other cultivations such as peach trees or orange trees? This is not the case. It could be a next project that we could propose to the European Union, but this is specifically about olive genetic resources. So the application works only for olives. We have a French question. Comment classifiez-vous une variété résistante ou sensible à une maladie ou un ravageur à partir de quel type de données? So this is a question for Freddy and Conchi. So the question is about how do you classify a variety as being less or more susceptible to a specific illness or pest?
Hello, Alicia. Okay, I will try to give a short answer. We did visual evaluation during 4 years in the 5 germplasm banks, and we get, let's say, a scale results from 0 to 10. 10 being the most susceptible with, let's say, full of symptoms, and 0 no symptoms. After that, we did the data treatment averages, and we grouped these, let's say, averages, these results in 5 groups. So we get the results of the cultivars, dividing them in 5 groups. From 1, the most resistant or less tolerant, to 5, the most susceptible or less tolerant. I hope that.
Yeah, but at the beginning, Alicia has explained it at the beginning of the presentation. One of the most important tasks at the beginning of the project was that agree in the evaluation protocols for every stress, for every biotic and abiotic stresses, and also for agronomical characters. So the different teams involved in this evaluation in the project, and mainly 5 germplasm banks, we agree in different protocols to evaluate all these characters with homogeneity, using the same scale, the same procedures during the whole project, in order to create solid data. All the evaluation have been done by 5 germplasm banks, but using the same procedures, the same methodologies. So every character has been evaluated following a protocol that had been agreed and followed by the 5 teams that have produced all the data. So that's why we generated all these results that are available in the web page.
Thank you very much for the answer. I think it was quite clear. When will the app be available openly? So this should be at the end of March, when the project ends. Everything will be available. We will send an email. So you have registered to this meeting, so we will send you an email to announce when the app is publicly available. How to access the platform? The platform is not available yet. So that is why you cannot access it yet. As I said, you will receive an email, and we will send you the link both to download the application and to access the website. So there was a question about, there is a tab on mobile app that is called Olive Detection. Does this work now? And if yes, do you use the user input to train your model? So olive detection and disease detection is something I will cover in the second part of this presentation. User data is not saved. It uses only the trained data, the one that we have used to train the machine learning model. Are there infos about salinity resistance? No, unfortunately, we have only the data that I have shown you on the slides. It might be data that would be added in the future if we have our projects that that support this, but at the moment, no, it is not available. Did you want to say something, Freddy? Sorry.
Yeah, I agree with you. By the moment, we have data that we get in the project. And the idea is that maybe in the future, if we continue with more evaluation, we can extend the database with more data.
Yeah, the idea is that this database is created and is filled with many data, but it can be improved in a large extent with more data, more cultivars. So we have created this database that now gathers a lot of information, but it can be better adding more cultivars and more evaluations. And I mean, we are up to do so in the future.
The next question is, can we find information about the quantitative meaning of the scales for each trait? So the information about the meaning of the scale for each trait, if you mean, for example, I can share the website again, just 1 second. Okay, so now you should be seeing the website. So if what you mean by this is this information here. So for example, I don't know, for fatty acid profile, the scale means, so you just need to click on the I and you see that information. 1 is low oleic acid content and 5 is high oleic acid content. You see a different one for each of the sections. So every time you have a different category here, then you have a detailed explanation here on what the scale means. And it's adaptive. I mean, every time you have a different explanation.
Yeah, Alicia, I think the question is also about the quantitative data. Actually, in the website, we don't have published the quantitative data because we need to process them more and publish in a scientific paper, let's say, no? So the idea is that the website will have a new tab that is not available right now, where we will all the papers that will be published will be linked to this website, and the users may find also the quantitative data in the papers, but it will be something more specific, not just grouping in these 5 scales, let's say.
Yeah. Also, the idea of this webpage was to be useful for a broad audience, not only for researchers or readers, but also for anyone who wants to know more or something about a cultivar. So we try to translate the information in the easiest way for that to be available and to be useful for a broad audience. And because of that, we translated everything to 5 categories that were easy to understand, and also is an easy way to describe the behavior of the different cultivars.
So we have another question that is about if there are recommendations before taking pictures. This I will explain in the second part. Allow me to skip this question. I will answer it in the second part of the presentation. All this information about varieties come from germplasm banks or also from farmers and experience. No, they all come from germplasm banks. So as I explained, we had to establish common protocols because before the project, there were many traits that were measured in different ways. So to compare it, it's really important that we know that we are talking about the same thing and measuring it in the same way. So I think that if we had, and please, Freddy, Conchi, tell me if I'm saying anything wrong, but if we had integrated also the data from farmers, it could have made this much more complicated.
Yeah, all the data came from the germplasm banks, as you said, that they were evaluated under the same protocols in order to standardize the evaluation.
So first we have explored what information user can find on the platform. And now we are going to explore the 2 AI tools that users can find there. So the GEN4OLIVE project has developed 2 machine learning tools that combined both cutting-edge technology and deep agronomical expertise. So I will first explain how these tools work, and then I will show you how you can use them. The first tool is designed to identify olive varieties using a single picture of the endocarp, which is the stone inside the fruit. So now, since the endocarp has unique characteristics for each variety, this tool can accurately determine which variety it belongs to. The second tool focuses on disease detection. So by analyzing an image of an affected tree, the model can identify potential diseases early. This can help farmers take action before the problem spreads. These tools, they were developed by Sapienza University of Rome. It was using the scientific data that was provided by the germplasm banks. And this combination really ensures a level of accuracy and accessibility at scale. Both tools are completely free to use, and they can be accessed on the GEN4OLIVE website and mobile app, making them really easily available to anyone who needs them. As I said, they are not yet available. At the end of March, you should receive an email with all the information about how to download them. So first, I will go through the technical perspective. I will try to remain really high level for those of you who are not too familiar with this technology, and then I will go into more practical considerations. So we've mentioned machine learning before in this presentation, but what is it concretely? Machine learning is a type of artificial intelligence that helps computers learn from experience instead of being directly programmed to do something. It powers a lot of technology around us, voice assistants, for example, language translation, streaming services, and so on. But how does that help in our case? So I can give you some examples of why machine learning can be particularly useful in agriculture. Machine learning, for example, can help predict crop yields, with much greater accuracy than humans. It can analyze climate data, past harvests, and it can make predictions about the future to help farmers plan ahead and manage their resources better. So that can help reduce risks. Then it can also be used in precision agriculture, for example. So instead of using the same amount of water, fertilizers, pesticides everywhere, machine learning can help by telling where they are needed. So it can also help adjust their quantity based on the area. So this can lead to cost saving, obviously, and also reduce the environmental impact. Another benefit, which actually is one that this project is tackling, is early pest and disease detection. So using image recognition, machine learning can spot health issues in crops before they become serious. This can really help farmers act fast and limit the damage that is done to their crops. So just to summarize, machine learning provides many benefits. It's more precise than humans to perform some specific tasks. It can analyze and process much more data than humans, and it can make connections between data that humans might not see. So now that you know a bit more about the technology from a high-level perspective, let me present Olivar to you. Olivar is the paper that presents the machine learning model that powers the olive cultivar recognizer tool. How does it work? So the model uses deep learning, which is a branch of machine learning that uses neural network with multiple layers to analyze large volumes of data. From a technical perspective, and I promise this will be the only really technical part, the architecture of Olivar combines a set of experts, which are 3 pre-trained convolutional neural networks, with a knowledge-based component that is called DenseNet. The predictions from the experts are integrated with those from DenseNet using additional dense layers. So thanks to convolutional neural networks, which are known for their ability to process and recognize images, and knowledge-driven learning, which improves accuracy, the tool achieves accurate and effective classification of olive varieties. So now, this might be a bit too technical, but something that is important is that for olive varieties, we have achieved a 96% accuracy in recognizing the variety. This means that 96% of the time, the model makes the right prediction about the variety that it sees, between brackets, obviously. With diseases, it's an accuracy of 94%. So it's important to note that these numbers can be improved. For example, let us say you scan one seed, you will get a 96% accuracy. You could scan different seeds from the same tree, and you can get close to 100% accuracy. This is valid also for diseases. You can scan the same diseases several times to make sure that you are actually analyzing the right disease. If you want to learn more about this technology, you can read the Olivar paper, which was published in the Journal of Computer and Electronics in Agriculture, and it's available for free online. The link is on this slide. The paper presents the variety recognition process, but both variety and disease recognition, they work exactly in the same way, and there will be another paper published for the diseases. The only difference between these two is that this paper, this olive variety recognizer was trained on endocarp pictures, while the disease and pest recognizer was trained on the part of the tree that was that had the disease or the pest that was affected. I will go a bit more into details in the coming slides, but if you have questions on the technical aspect, please feel free to ask, and I or my colleagues will be happy to answer. So now, if we put Olivar aside for a moment, it's important to mention how olive varieties are usually identified. There are two traditional ways. One is morphological analysis. So this option is usually conducted by experts who have to manually examine the shape of the endocarp. This evaluation is usually done in batches. So this means that the experts evaluate seeds against one another to determine the variety. Obviously, this process is subject to human error, and it requires the expert to have physical access to the seeds, which can be sometimes costly, but more than anything, impractical. Moreover, experts are trained to recognize only a specific number of varieties. The second option is genetic testing. This option is conducted in a lab, and it is quite costly and it takes a long time. On top of that, only a handful of scientists who have both the expertise and also the access to the machine can handle this process. And of course, the biggest issue is scale. When you're dealing with large amounts of samples, traditional methods simply are not practical, and rare varieties are especially hard to identify. So Olivar bridges this gap by offering a fast, cost-effective, and scalable solution for olive variety identification. It provides several benefits. Instant image recognition. So Olivar provides an immediate result by scanning an olive endocarp. It is quick and it is efficient. It addresses human limitations because CNNs can detect morphological details that are beyond human perception, enhancing the accuracy of the identification. It's adaptable, it's scalable. Unlike static methods, Olivar is not limited in the number of varieties it can be trained to recognize. It improves accessibility because it has a user-friendly interface, and it is accessible to a wide range of stakeholders. And finally, it provides a free alternative. It offers a cost-free solution for those who might not have access to experts or genetic testing. So we have covered why Olivar was created. Let us see a bit more how it works, and then I will move to how you can use it. So to explain it in a simple way, I will walk you through the steps that we followed to develop the algorithm. The starting hypothesis, which is backed by science, is that the endocarp, the stone, is a reliable predictor of the variety. There is sufficient variability in the endocarp for a human or a computer to distinguish between varieties. This is what you can see in figure 2. This is precisely what experts analyze when they are conducting the morphological identification. So before working on the model itself, we collected thousands of images of endocarps, and specifically our wonderful germplasm banks provided 2 images of each seed, with the second image taken simply after rotating the seed 180 degrees along its vertical axis. This is what you can see in picture 1. So for each variety, we collected around 1,200 pictures, and this was a really labor-intensive process. Each seed had to be photographed, following a strict protocol to ensure consistency. But thanks to the work of our germplasm banks, we actually reached a really high accuracy. Then each of these images is paired with a label. The label simply tells the computer what it is looking at. So in our case, the label is the name of the olive variety. So this allows the model to learn which characteristics correspond to each variety. So to summarize, this first step is about preparing a large, high-quality data set that the algorithm is going to learn from. After gathering and labeling the images, we need to transform them so the computer can analyze them properly. So unlike humans, AI can identify patterns that remain stable across images, even if they are not obvious or meaningful to the human eye. This process is called feature extraction, and it helps the AI recognize the key characteristics of each variety. Here are the transformations that we made to the images. The first one is grayscale conversion. It removes color information, so the model focuses on shape and texture. This is what you can see in figure 1A. Then there is local binary patterns. This highlights small texture details by analyzing pixel intensity differences. This is the B in figure 1. Then the last transformation was discrete wavelet transform, which captures patterns in different frequency range that help identify subtle morphological traits. It's the C in picture 1. So then what we do is that we stack with these three processed images together, and this is the combined image that the model is going to analyze. So to summarize this step, we transformed the images, we stacked them together to prepare images that the model could learn from. Then once the images are processed, we let the model start learning. The model is shown thousands of labeled images, and it learns to recognize patterns that define each olive variety. Here's how it works. The model first analyzes an image, and it makes a guess about what varieties it sees. If the guess is wrong, the model is going to adjust its internal settings and is going to go back to analyze the data again. Now, this process repeats thousands of times, constantly refining the model's ability to make accurate predictions. To explain it more simply, each time the model makes a mistake, it learns from the mistake that it has made. And over time, it's improving its accuracy until it can reliably recognize olive varieties based on the extracted features. On this figure, you can see the architecture of the model. This is pretty much how the components are organized, and they interact between one another to process data and make decisions. To put it in a simple way and to give you a bit of a metaphor, you can think of it as an architect planning the layout of a house. You choose how to, the expert chooses how to arrange the rooms, the doors, the windows to ensure that the house functions well. In machine learning, the architecture is really what defines how the model and the units are arranged, and it helps the model process information effectively. So this design is really important because it determines how the model will learn from data and perform tasks. And last, once the training is complete, the model is ready to analyze new images. This process, that is called inference, allows the users to get an instant prediction based on what the model has learned from the training data. Am I running long, Freddie? I see that you activated your camera. Am I taking too long? Okay,
no,
I keep going.
Alicia. It's just
okay. I thought you wanted to say something. Okay, perfect. So once the training is complete, you reach this step that is called inference. And here is what happens when you upload a new image to the model. The model is going to compare the variety that the image that you have uploaded to what it has learned. It's going to calculate the probability that the image belongs to each variety. So we're going to get several predictions. Here, for example, you see that you have Arbequina that was predicted with 99% confidence and anthracnose with 99% confidence. What does this percentage mean? So when you upload the picture, the model is not going to give you just a simple answer. It's going to provide a confidence score for each possible variety. So for example, if the model predicts a variety with 99% probability, it means that it is highly confident that this is the right identification. If you have two varieties that have 52% and 48%, for example, and the percentages are really close, it means that the model is less certain. This might indicate that those two varieties share morphological traits. In that case, if you have two percentages that are really close to one another, you can scan multiple seeds to improve the identification's accuracy. So I hope the technical perspective was not too complex, but now I will go through the user perspective, which could be more interesting for some, and explain how you can concretely use the tool. So to ensure accurate recognition of the seeds, the endocarp really has to be clean and clearly visible before you take your pictures. This is the result that you are expecting to obtain after following the cleaning process. You can see it in figure 1. As you can see, the veins are quite visible on this picture, and the pulp has been completely removed. If you are not a professional, you can still do it. It's not going to require too much material. You will just need a synthetic mesh or a soft brush. You can use a toothbrush, for example, a bit of bleach, and plastic bottles if you want to conserve the seeds. So here is how you have to prepare the seeds. The first step is to remove the pulp. For this step, we recommend freezing the seed overnight because it will make the pulp removal easier. Once frozen, you have two options. Either you are a professional and you have a pulper machine, so you can use this, or you are not a professional and you will have to do manual cleaning. So you're going to use the synthetic mesh, raw fabric, or the soft brush under tap water to remove the pulp. Don't use metallic tools because they can damage the seed surface and they can alter key morphological features that the machine learning model has to analyze. So if you damage them, it's not going to be able to analyze them properly. Then you will have to clean, bleach, and dry the seeds. This is what you see in phase 2. So once you have removed most of the pulp, you will notice that there's still a bit of pulp. So you can scrub the remaining pulp simply using the soft brush that you have at your disposal. You do it until you have removed all the pulp and you have the endocarp veins that are fully visible. This is the last part of the phase 2 process. Next, the seed needs to be bleached. So you will have to prepare a 10% bleach solution. This means 10% bleach, 90% water. You will soak the seed in the solution until it starts turning pale. This should take only from 30 to 60 minutes. And then you dry the seed at room temperature if you're not a professional, in a 37-degree oven if you have professional equipment. The last step is to label and conserve the seeds. This is only if you want to keep them. Once the endocarp is dry, you can store them in plastic containers, as shown on the third picture. For disease recognition, it's much easier. You just take a picture of the section of the tree that is affected by the disease or the pest. So here you have two examples. In figure 1, you have a branch that is affected by the peacock spot disease. And in figure 2, you have a fruit that is affected by olive anthracnose. Now, the algorithm was trained to recognize different things. It can recognize pictures of leaves, can recognize pictures of fruits, and it can recognize pictures of trunks that are affected by the disease or the pest. Now that we have our clean seeds or that we have access to our diseased tree, we can take the picture. We make sure to take a clear picture with enough light, obviously, and without using the flash. After taking the picture, it should look like this. So on the left, you have an image of an endocarp, and on the right, you have an image of an olive that has been affected by a disease. You then upload the picture to the tool. I will show you how to do it in the demonstration. Now we let the algorithm work its magic. The AI is going to extract the unique morphological features from the image and is going to compare them to what it has learned during the training phase. Then you will get your match. The algorithm is going to display a percentage that, as I explained before, represent its confidence in the identification. For example, here the model predicts anthracnose with 99% confidence, which means that the algorithm is almost certain that the picture we uploaded is a fruit that is affected by anthracnose. So an important point to keep in mind is that we do not store your image. Once you upload an image to the platform, it is processed to generate a prediction and then it's immediately deleted. To make the most out of the tool, please avoid these common mistakes. Don't overclean the seed. The veins need to be visible. You can have a look at the pictures for reference. There will also be the protocol on the website in case you have a doubt. Make sure that you take the picture with enough lighting, and also make sure that your image is not blurry. If you do not follow these steps, you might have an incorrect identification of the fruit or the disease. So let us, I'm going to show you how to do this yourself. Okay. So this is the section that we're going to explore now, the AI tools section. Here you have the access to the two tools that we have mentioned. There is first the olive cultivar recognizer, and then there is the pest and disease recognizer. Let us go to the olive cultivar recognizer first. So on this page, you will have access to several information. Here, you will have the protocol. So everything that I have explained to you right now on how to prepare the seed is going to be present here. You're going to be shown how to remove the pulp here, how to dry here, and how to take the picture here. You then click to proceed to the variety recognizer, and you can upload a picture. So if I click here, I have the picture on my computer that I can upload. I'm on the variety recognizer, so I need to upload a picture of an endocarp. I'm going to show you two examples. I upload this picture, and I get my match. So here I have Aleph with 99% confidence. This means that the algorithm is pretty certain that this variety is Aleph. Now, it's not 100%, so it's giving me also other matches. So it has analyzed all the data it has learned from, and it realized that some of the morphological characteristics are also close to other varieties. These are these two varieties, Uovo di Piccione and Azersat. It's 0% confidence, so obviously I'm pretty certain that this is the right variety. So let us say I want to have more information about that particular variety. I already have the picture here to see how it looks. I click View Details, and I find the entry in the database about this particular variety. As we said before, usability synonyms, all the pictures, and specific information about this specific variety. So you can explore all of this after you have analyzed the seed. The pest and disease recognizer works exactly in the same way. So I'm going to show you again. You go here on top, AI tools, pest and disease recognizer, click here. You're going to have the protocol, which is much simpler for diseases. So it's going to explain to you how to take a picture of the leaves, how to take a picture of the fruits, and how to take a picture of the trunk section that is affected by the disease or the pest. You click here, proceed to the olive disease recognizer. You upload your picture. Let us say I upload this picture that I showed you in the presentation. And I get my results. This is 99% confidence that this picture that I have uploaded of a fruit that has been affected by a disease is affected by anthracnose. Now, this is not available yet, but there will be a button here that you can click to have more information about the disease. I'm going to show you how to do exactly the same thing on the application now. Obviously, you can scroll down here as well, and you will see the other predictions. Something I can also show you is that the model was also trained to recognize. Please tell me, Freddie.
No, it's just that we could not see the step of uploading the picture, as you have shared just the one tab, I think, or something like that. We couldn't.
It's because I shared the. I can share my screen instead,
if possible.
I will show on the mobile. So I will share my whole screen for the mobile so you can see how I do the process. The model was also trained to recognize healthy branches, for example. So I can show you what happens when I upload a picture of something of a healthy branch. So here you should be able to see the picture this time. I'm going to upload this picture, submit, and the model tells me that it is 99% confident that these are healthy branches. So I can be pretty sure that those are healthy. So let me show you on the application. So on the application, you're going to go on these two sections, olive detection and disease detection. If I click on olive detection, I'm going to share just the application, otherwise you're going to see everything in the background and it's confusing. Like this, it's better. So you have these two sections, olive detection and disease detection. Here, I click olive detection. I can take a picture or I can upload a picture. So here, select from gallery. Let us say I want to analyze this seed. Detect, and I get my match. Here I have the 100% confidence that this is because this is rounding it. So it's close to 100%, so it's rounded it to 100%. I can click on the left and I will have the same information that you found on the website. Now I can show you with another picture, just to repeat the process so you see well how it works. I could upload this one. As you see, we have cleaned the seed. The veins are visible. I press detect, and I have 100% confidence that this is Arbequina, so I can be pretty sure that this is Arbequina. I can click here, and I will have all the information displayed about this specific variety. For disease detection, it works exactly in the same way. The only difference is on the website you cannot take a picture, whereas on the application you can either take a picture or select from gallery. So here, let us say I want to analyze this disease. I press detect, and the model is pretty confident that this is black scale. I cannot click it yet, but later on there will be information about the disease. So I want to try with another picture once again. Select from gallery. Let us take a healthy branch this time. I add, detect, and the model is pretty certain that these are healthy branches. So this is how you use the tools. It should be pretty straightforward, and here it should be pretty straightforward and easy to use. But if you have questions, please feel free to ask. And I will be taking questions now, actually, since we finished with part 2. Will there be any recommendation on how to recover from disease? So this is something that Fred is currently working on with Professor Itai. Freddy, can you tell us exactly what will be in that section?
Sorry, one more time the question, Alicia.
You know, when I analyzed the disease and I said that there will be a section in which we will have information about the disease. Mm-hmm. There is a participant that asked if there will be any recommendation on how to recover from the disease. It seems to me that this is the case, but I would like you to confirm.
Yeah, we are working on this section yet. The idea is to give small information about the importance of diseases, the most problematic period of the year that this disease may affect the olive cultivars, and maybe some light recommendation about the treatment. I mean, which could be the most useful treatments, but just general information or recommendations.
Can we use the application in detecting any problem in a field, like any abiotic stress? So the only diseases and pests that you can detect are the ones that I have mentioned in the previous slide. So let me go back to it. I can show you again. Those are the only ones that you can detect: Verticillium, Xylella fastidiosa, leaf peacock spot, Cercospora leaf spot, olive anthracnose, nose, and olive fruit fly. Anything that is not mentioned here was not. Please, Fred, tell me.
No, but sorry, this is the list of diseases that are available in the website with the characteristics of each cultivar. But the list of the diseases that we trained the app is longer. I mean, I will share it now with you. Okay.
Okay. In that case,
are about
okay.
13. I will share it now with you. Okay. But we cannot detect the abiotic stresses. It is not training. Let's say the model is not training about the abiotic stresses. Okay. I will share now the diseases that we have photographed.
Someone asked, you said that we will have the app and website ready for everyone after March. Yes, end of March will be available for everyone. Can we have the presentation? Yes, the slides and the presentation will be uploaded online and you will have access to it. What is the lowest % confidence for the cognition of varieties and diseases? Is there a minimum?
There is no, can you hear me?
Yes.
Okay, so there is no specified minimum. I mean, what you can consider usually is like we always will present top 3 predictions that the model has a certain amount of confidence. And of course, they are of course ranked. So the highest prediction gives the highest probability. My colleague mentioned also before, in cases that you notice a certain amount of doubt that the confidence, for example, is not that high for the top 1 prediction, you can actually, in the case of diseases, try to take other pictures so you can actually get more confident as you see how the model behaves to different photos of the same conditions that you are taking. So basically, for example, of an fruit that you have a suspicion that has been suspected by a pest or a certain disease, you take different pictures of it or other fruits that you find on the tree, and you can actually get more confident about the prediction that the model gives after you try it several times. Similar is valid also for the variety recognition.
There are other questions for you, Dorian. There is a question about the chances for the AI to give 2 varieties for the same endocarp. I guess this means what are the chances that it gives 2 different varieties or closer results, I assume. So what I think is that if 2 varieties have really similar morphological characteristics, then this will happen. Otherwise, if the morphological characteristics are really, really different from the other varieties, this is less likely to happen, if you can confirm.
So yeah, every time the model, as I also mentioned before, it will present you the top 3 confidences. And for example, if a variety, if 2 different varieties, for example, have an endocarp with morphological traits that are extremely similar, how this is translated in actually like the behavior of the model, it means that, for example, that his confidence would be more or less split between these 2 or these top 3 predictions that we give. For example, if you see the first one that it says Arbequina with a confidence of 55%, and for the next one you see that like 40% on that is confident that is, for example, Koroneki, and for the third one it says 5%, you might see that, for example, the 2 top choices that they give you, he is biased between these 2 varieties. So maybe he thinks that the endocarp belongs to either this one or the other. So he's not completely sure. And also in this case, I would like to reiterate again what I also previously said, that in cases such as this, we highly advise to actually try and test the model with multiple seeds of the same variety to actually get a better boost of the confidence of whether it is, for example, in the case that I mentioned, being Arbequina or Koroneki or varieties that have similar morphological traits. I also want to reiterate only one thing, since we are in the topic of it. A machine learning model, you can think of it as just a very wise human that is actually able to recognize it. So it is, of course, as we said, prone to errors, prone to uncertainty, and this is just a better way to actually handle more efficient data compared to a human being in that case, because it can actually learn and memorize much more information. So it can do the job efficiently. But as we also have to stress that it has to be used in specific manners so you can actually get the best out of it. So as also my colleague said, the users are highly encouraged to actually follow the procedures for the cleaning of the endocarps, for example. They are also highly encouraged in case of uncertainty to actually test it with multiple endocarps, cleaned endocarps, following the procedure, and so on and so forth.
Okay, thanks, Daria. Alicia, I just shared with you the list of diseases that the model were training. I think you can not see very well the PowerPoint. Maybe now. Can you see the picture?
Yes, I can see it.
Okay,
so there are much
this
more
is,
diseases than the one we actually
yeah,
added to the platform.
13 diseases and 3, let's say, healthy tissue, leaves, fruits, and trunks or branches, in order to make the contrast for the model, to detect between healthy and unhealthy tissue, let's say.
Can participants actually evaluate these diseases with the disease recognizer tool?
Sorry?
Can the participants actually analyze these diseases with the disease recognizer tool?
Yeah, they can detect all these diseases with the app.
Okay.
And insect symptoms.
So we had some question. Does the program go on keeps learning after the launch in March? So this is not the case. However, there are other varieties that will be slowly added to the platform, right, Friday? I know that there are some varieties that are planned to be added for the information in the library. But as far as the Olive Recognizer tool is concerned, the varieties that are there are definitive, right?
Yeah, I mean, the varieties are the definitive for the moment, because when we upload a variety, we need to have the pictures, the agronomical descriptions, the evaluations. So in the moment we have evaluated more cultivars using the same methods, the same protocols, they will be uploaded. So that is the condition, that we want a database where the cultivars have been evaluated and characterized under the same protocols in order to provide that reliable information. As soon as we have more cultivars characterized in this way, they will be uploaded. Is what I said at the beginning. We have created the architecture, the database. Now we are able to implement this architecture with more data. The same for the applications, the 2 applications. We have trained the models with thousands of pictures, and they have now an accuracy. They can be better in the future if we continue training them. So I would like just to say that we have created the architecture, we have created the engines, but now these engines can be more powerful in the future if we feed them with reliable data. And that is the point. We want to feed the database and the applications with reliable data. As soon as we have this, we will feed them, and they will be more powerful. But this is the condition.
We had a question that was about if users wanted to add more data. Sorry, I have lost it. How can we enter olive varieties which are not yet on the platform? Shall we send the data to you? Thank you. I don't think this possibility was planned.
I mean, I think that I already answered this question in my previously. I mean, we are open to include more cultivars for sure. We are open to include more information from germplasm banks, but we want to include true to type cultivars and well characterized cultivars, and I mean, well, using the same protocols in order to provide strong, bold information in this database. The origin of the GEN4OLIVE project, or one of the main goals of the GEN4OLIVE project, was to provide reliable information, because so far we had information from many cultivars and we didn't know if they were real cultivars, synonyms, and many of them were analyzed using many different protocols, so the information was not comparable. The GEN4OLIVE database is trying to avoid this, and because of that, we are providing information of 600 cultivars that had been evaluated using exactly the same protocols. So as far as this condition is fulfilled, we are open to include more cultivars for sure. This is a public resource and we want to make it as powerful and meaningful as is possible, but with strong and meaningful information. And that is the condition.
Thank you. Dorian, there is another question for you, which do you know of effective AI models for predicting olive yield based on agricultural climate data? I mean, here we evaluate frost tolerance and drought tolerance, but I don't know if there are other models that you know of that do this specific task.
I mean, different kind of tasks can be, you can resort to machine learning techniques to actually try to get better predictions, better insight, apart from like the usual correlation that you do on historical data, for example, since you are mentioning the olive yield. Given the type of data that you have, you can see if you can frame that one as a machine learning task where the data that you have can actually assist you to actually understand, for example, through, let's say, I don't know, by observing, as far as I've seen, I have seen once some hypothesis attempt on trying to, like, for example, calculate the loading with olive fruits of a whole olive tree through history data and so on and so forth. I mean, the opportunities are wide, so basically it depends on the task at hand and also the ability to gather the right amount of data. So basically you need the right resources and the right amount of time to actually be able to employ machine learning techniques, so these AI tools, also to other tasks related to the olive or even other cultivars, typically like other fruits and so on and so forth.
Yorgos had raised his hand, so I'm just going to give him the spotlight. Here, I unmuted you, Yorgos, if you want to say something.
Okay, thank you very much.
Hi.
Hello, everyone. This is Yorgos Kumbouris from Greece, from Lgo Dimitra, the National Organization for Agriculture Research and Certification and Training. What I would like to add in this for this question is that the Joint Research Center of the European Commission has a working group in progress that will develop a European system for forecasting olive yields. So this system will use meteorological data, data about the olive groves, satellite images, and the modeling tool and it will provide an annual forecasting model for olive yield. So this is something that will be available soon. And this project exploits and uses also experts from the GEN4OLIVE project. So these two are very well related, and we are in a very good way to achieve this goal very soon.
Thank you so much, Yorgos, for your insights. I saw that there was a question about if we can take picture of diseases directly in the field. Yes, this is possible. We put them on a white background because for us it was better to analyze them that way. But it is possible to take the picture directly in the field. What I suggest is that I go through the end of the presentation and I will take the rest of the questions after. So if some participants want to leave because they do not want to stay for the Q&A, they can do so. So let us go back to where we stopped before. So we had seen how to upload a picture and get a prediction. We have navigated the AI tools. I've asked some questions, and now I'm going to go through two examples to help you understand how to use the tools in your daily operations. These are fictional examples, just to give you an idea of how they can be used. The first example is the example of Marco Rossi. Marco Rossi is a third-generation olive farmer in Puglia. He manages a 30-hectare growth and his family traditional mill. Recently, he has noticed a decline in both yield and oil quality due to an unknown disease. Concerned about the long-term impact, he wants to identify the disease and find a sustainable way to protect his growth. However, he lacks access to reliable information on which variety would thrive in his region while offering better disease resistance. So the challenge of Marco is that he needs a quick way to diagnose the disease in his orchard to take the necessary measures. He would like to find a long-term solution to protect his growth without relying too much on pesticides. So first I will walk you through his journey, and then I will show you exactly on the website how to do all these steps. So first, Marco uses the GEN4OLIVE disease recognizer tool to diagnose the unknown disease that is affecting his growth. This tool allows him to quickly determine which disease is present, ensuring that he understands the problem before proceeding. Having a clear idea of what he is dealing with, he can now consider possible solutions. He reads more about this disease affecting his plants. He realizes that it is olive anthracnose. He realizes in his region. That worries him because Marco doesn't just want a short-term fix. He wants a long-term solution. If he does not do anything, it will get worse in the future. So he decides to look for olive varieties that are naturally less susceptible to this disease. Adaptation to his region climate, obviously, and also high oil yield, because this is particularly important for him. After applying these filters, the platform gives him a list of matching varieties. Each entry includes detailed information on resistance level and yield, so Marco can clearly see how each variety performs. Marco then carefully reviews the suggested varieties, and by comparing the data, he can create a short list of those that strike the best balance between low disease susceptibility and good oil yield. With this reliable data, Marco is able to make a more informed decision about which tree he wants to introduce into his grove on the long run. So these are the different steps that Marco follows that I have run you through. Now I'm going to show you how to take the exact same steps on the website. So first we have said that Marco needs to identify this disease that is affecting his growth, right? So he goes on the AI tools and pest and disease recognizer. He clicks here. He selects the disease, the picture, of the disease. He wants to upload a picture of the fruit that is affected by this disease. So here it's this fruit. He submits, and then he gets a match. In this case, he realizes with 99% that the system is 99% confident that it is affected by olive anthracnose. So since there is no information yet on the platform, Marco does a bit of research online. He wants to understand more about this disease that is affecting his plants. And he realizes that it's really thriving in his region. Since he's worried, he wants a fix that is not just a short-term fix. So he would like to know which varieties are naturally less susceptible to this disease. So to do so, he can go on the interactive olive database, interactive filtering right here. And we said that his criteria are 3 criteria. The first one is he wants a high oil yield. So we can input an oil yield that is between 4 and 5, because 1 is low and 5 is high. Then he wants low susceptibility to olive anthracnose. So this is in the category pest and diseases. Low susceptibility is 1. So let us say he puts it from 1 to 2. And then he's in Italy, I don't remember if he's in Sicily, he's in the south of Italy. So he also wants low susceptibility to drought. So he can input this as 1 to 2. Then he searches. And he finds 4 varieties that are that match his criteria. One of these varieties, for example, is Arbosana, which is a cultivar that has traces its origin back to Spain, and it is an oil cultivar. So we click on View Details, and here we have more information about this specific variety. He can read about all the information about this variety in this page. He was particularly interested in yield, so we can see that, yes, this variety performs pretty well in oil yield. Then he wanted low susceptibility to olive anthracnose. So let us see if we have input that in the filters. So it should be, yes, it is low susceptibility. And low susceptibility to drought, which is here in climate information. And we can see that, yes, it does have a low susceptibility to drought. Now he could play a bit more with the filters, and he could add additional criteria. But this is pretty much how someone could use the platform to find a variety that suits their needs. So now I will show you a second example, and then I will take some questions. Our second example is the example of Ines. Ines is an olive producer and a reseller in Meknes, Morocco. She has been producing olive oil for 15 years. Her grove contains various varieties of olives that she uses to produce olive oil. She would like to expand her business by also selling attractive table olives to local businesses. Since her grove already includes multiple varieties, she'd like to know if any of them are suitable as table olives. If that were not the case, she would like to explore which new varieties she could introduce into her grove to diversify her operations and grow her business. So the challenge of Ines is the following. She needs a fast and efficient way to assess both the variety and the table quality of her olives. Specifically, she wants to determine if any of her current olives can be sold as table olives. And if not, she would like to know which varieties would be better suited for that purpose. So once again, we can walk through Ines's journey. I will show you how to perform the same actions after that. So Ines first wants to analyze the varieties that she already has in her grove. To do that, she's going to collect several seeds from each of her trees, and she's going to make sure that she has enough samples to get accurate results. She's then going to clean the seeds, following the protocol, and then to take clear pictures of them. Now, she wants to take some time to analyze the data on the website, so she wants to be sitting in front of her computer to analyze the images. So she goes on the website, she uploads these photos to the GEN4OLIVE recognizer tool, and the platform shows her that she has 4 different olive varieties in her grove. She then looks up each variety in the library, paying special attention to their oil yield and if they would be good table olives. And through this process, she finds that one of her current varieties could be sold as table olives, the Arbequina variety. Still, Ines is curious. She wants to know if there are better table olives varieties out there. So she checks the platform's recommendation to find out which new varieties might be worth introducing into her groves in the future. Once she has this information, she can make a more informed decision. So she can decide which varieties to keep for oil. She can decide if she wants to convert some of her trees for olive tables, and she can decide if she wants to plant new trees into her grove. This helps her build her business confidently because she's minimizing risk, ensuring that she provides a product that is adapted to her clients' expectations. So I'm going to run you through what Ines could do on the website. Ines is preoccupied about, she wants to grow her business, right? And she wants to know if some of the olives that she already has in her grove could be used as table olives. So she's going to upload different pictures of different seeds in the olive cultivar recognizer. I'm going to do the process only once. So, I mean, if you know how to do it once, you know how to do it 4 times. So proceed to the variety recognizer, choose a file. You're not going to see me selecting the file, but it's fine. I showed you before. Submit. And she finds out that this variety, Arbequina, is one of the varieties that she already possesses in her grove. She clicks on View Details, and she's going to find information about Arbequina. She sees here that it's a dual-purpose cultivar, so this means that she can use it for oil and she can use it as table olives. She checks this section in particular, table olive aptitude information, where she finds information about the table aptitudes of her olives. So she has the fruit volume, the fruit bruising index, the fruit length, the fruit width, shape index, and symmetry. Now, if this is satisfying to her, she could decide to repurpose some of her olives. But let us say she wants to see if there are better varieties for that purpose. She could go on interactive filtering right here. And let us say these are the criteria that she wants. Usability, we said that she wants dual-purpose cultivars. So we select this here. We said that she wanted high olive yield because it can be used for either olive oil or table olives. So let us say she puts a range from 3 to 5. Then she wants resistance to drought because she noticed that this is it's a big problem in Morocco right now. So she inputs 3 to 5 on drought sensitivity. And then let us say she wants to add an additional criteria, which would be, I don't know, fruit load, but she wants her fruits, her trees to bear a lot of fruits. So with these 3 criteria, she can click Filter Olive Varieties, and she is going to have a list of varieties that match these criteria. We can see, for example, that one of these varieties is Koroneiki. If she wants to see the profile of Koroneiki and have more information, she can click here. And as usual, she will have all the information that she needs here. Confirms that it's a dual-purpose cultivar, can check information about yield and quality here, climate adaptability here because she wanted high drought resistance. And finally, she can check if Koroneiki is suitable as table olives. So this is what Ines could do if she wanted to have more information about which varieties to keep and which varieties to sell as table olives. So I hope that this was interesting to you. And if you still have questions, please feel free to ask. And now we have reached the end of this presentation. So I will take the remaining questions and then we will conclude the meeting. Can we as agronomist engineers contribute to this research project? And there is also a question about if PhD students can find research projects in this field. So both agronomists, engineers, and PhD students are asking.
But I couldn't understand the question about the agronomist engineers. What is the question?
How agronomist engineer can contribute to this project?
How can contribute? Actually, the project is closing. we are in the end, but in general, all the stuff that, I mean, the most people of the staff that has worked on the project have been agronomists, but also from other profiles like from chemistry, informatics, etc. So in this moment, we don't have a...
No, I mean, I think that any agronomist that is dedicated to olive can somehow contribute adopting the characterization methods and evaluation methods that we propose in this database. In that way, we could implement the database with more data.
If I may say something while we wait, this project, this GEN4OLIVE software platform is the result of collaboration. Among the partners to the project, and as a, I would say, there is a shared vision in this platform for the future of olive cultivation. So the project is, of course, is ending, but as we move forward, I would say we should explore the platform also with the help of the olive breeders, the researchers, and the stakeholders. We should explore the platform, have feedback, and somehow continue the journey, regardless of the fact that the project is finishing. Because I think this kind of vision can have the vision that led to build this.
Is it cost effective to replace older varieties for new ones in order to establish more resistance to diseases?
I mean, this is something that this database and these applications are not built to answer. The idea of this database is to provide information about 600 cultivars to help farmers, breeders, researchers to take decisions. So the decision is on their side. This is this is a database that provides a lot of information, and we think that it is a milestone in the information available for all the olive sector. But for sure, the decisions are on the side of every farmer, every researcher, every breeder. So they have to evaluate if for them is more profitable to substitute a cultivar by other. That is not our intention with these tools. These are tools to help to take decisions, but the decision is not on our side for sure.
There's a question which is for Dorian. Will the user be able to give feedback on the performance of the models?
For the moment, it's not foreseen on this. But thank you for the advice, because it's something to be considered for the future.
There's another question that is also for you. How to proceed in the case of resemblance between two diseases? How can we have a better identification if two diseases are really close to one another?
So, I mean, as I think I also mentioned briefly earlier, you can proceed with multiple pictures to do multiple predictions and try to get a clear picture of whether the model is telling you about one disease or the other. We should not also exclude the cases that, I mean, it might happen that the tree in itself, this variety in itself, has been infected by multiple diseases. So, for example, what I would assume, I mean, also the agronomic experts on the team can actually try to add on about it. But for example, if I actually predict multiple times different pictures in different conditions for this variety, and I keep getting answers that the model is, let's say, split between 2 or 3 diseases, maybe actually should be also considered the case that this variety might be infected by these 2 diseases, for example, or 2 different pests. So that one can also be considered as something to consider while observing this kind of behavior from the model.
Another question for you is, what are the chances of a wrong diagnosis?
What are the chances of the wrong diagnosis? So to answer to that, I also need to give you also a bit of like just a background on stuff like that. So a machine learning model is as good as the amount of data that you are able to be fed to it. So amount of data that it learns upon. Now, given the large amount of data that had to be collected during this 4+ years of the duration of the project for multiple varieties, at least for the variety recognition, our partners from Córdoba and the whole consortium try to do their best about gathering us rich and diverse enough data sets. But to be honest, from the point of view of computer science, I would say that data is never enough. So the models can always be improved with more data and better and more variable pictures, for example, for the conditions of the diseases in different maturation phases, for example, and so on and so forth. So as we also have put a little disclaimer on that, the predictions that the models give are to be taken with a little bit of a grain of salt. I mean, they work exceptionally well, and we are also impressed with their performance. But you have to know that these kind of predictions are always probabilistic, but also in the confidence that it provides, you also should take it with a grain of salt that in some cases, these models do make mistakes because this is how they are constructed. This is lies in their foundation. They perform generally, the keyword is generally, they perform exceptionally well, but they might be edge cases that they might fail to actually perform as expected. So to actually conclude my answer on this is, you cannot expect a machine learning model, not this, but in any case, in any model that you might consider, to be fully precise for every possible case in the world, because you can also think it from this point of view. I'm going a bit more technical right now in a second, but for example, how many different conditions of a certain image you can take? There are infinite amount of conditions that you can take, because even if you vary even a certain pixel of a grid of an image, you can take a lot of stuff. So basically, you cannot encompass an infinite number of cases into a learning algorithm as such. So as I said, I concluded with like, take the answers that these AI tools give with a little bit of a grain of salt to actually be able to actually exploit them to the full potential. So be always doubtful, try them again. If you are not convinced, try a bit some more, then try some other techniques to actually be more sure about the stuff.
We have a question from someone from the Agricultural University of Tirana in Albania, but the question is regarding the Olivar paradigm. Can it be used to tailor? Can it be used and tailored in olive oil fraud detection? Thank you.
So I didn't get the question.
The question is regarding the Olivar paradigm, if it can be used and tailored in olive oil fraud detection.
Fraud detection, you mean? Well, to be honest, I'm not particularly aware of like in what terms you mean fraud when it comes to like these fruit varieties. But yes, I mean, the Olivar paradigm in itself, or I would try to make it a bit broader, so like machine learning in itself can actually be used to actually detect that somebody is trying to, let's say, sell you arbequina for Koroneki, for example, like trying to fake something between varieties. And in that case, you have a different task at hand, but you can actually like verify that also, like, for example, what it is being told to you, like with variety, using the endocards of the proposed variety, you can check whether the model actually agrees with you. So basically, the kind of application can be done also through the variety detection. But of course, I have to reiterate every time, like, you cannot take every prediction that the model gives as actual facts. So like it is, in general, it will actually be very useful, but always consider it as it is intended to be, an assistant. It is not the law of God when an answer that these models give you. So as yes, the answer to that question is yes, it can be used in fraud detection, of course, if used appropriately.
Yeah, if I can add something, Alicia, to agree with Dorian, but actually these two apps or two models has not been designed to let's say detect fraud detection in olive oil specifically. Actually, there can be other data entry like chromatograms or whatever that could train another model to make this kind of let's say detection or kind of analysis to classify olive oil as authentic or not, or as fraud, if there is fraud or not.
There was a question that was interesting about how does the program react to varieties and diseases which are not in the database. So it will be made clear on the platform which diseases you can scan and which diseases you cannot scan, right? Because if you scan the wrong disease, the program is going to start to try to make a prediction about that disease. So there will be information on the platform telling you, okay, these are the diseases that are supported. Then it's up to the user to actually take this information into consideration. Please correct me if I'm wrong, or you can add something if it's not enough information.
Yeah, I also would like to add that, for example, the app was trained with 130 cultivars. So if another cultivar is, someone wants to identify a cultivar that is not in this database, in this set, the program, the app will provide the most similar cultivar that it finds. So that's the point. So far, the app has the data of more than 100 cultivars. For sure, are not the 600 that we have characterized for the database. But in the future, the more data we provide, the more picture, the more we feed this artificial intelligence, the more the accuracy of the model. So if someone wants to identify a cultivar that is not in the database, the algorithm will answer the most similar one. The same in the case of the diseases and pests. But I mean, it's just an approximation. This, as I have said before, the database and the two apps are that we have created the engine. We have filled with many data, but it's never enough, as Dorian said before. The more data we provide, the more reliable data we provide, the more powerful this application will be.
Would it be possible, maybe in a future program, to add information about electrical conductivity and other sectors about irrigation scheduling? So this looks like a really technical question because I do not know what electrical conductivity has to do with crops. So maybe I can ask you for some information on that.
As far as I know, electrical conductivity is a characteristic of the soil or the irrigation water. This database, our purpose is to characterize cultivars. Other related question could be if in the future, for example, we will evaluate the tolerance to salt or to limestone. Maybe in the future we will add more evaluations, but this will be in the future. And of course, once we have defined common protocols to evaluate in the same way all the germplasm banks. But the idea of this database is to characterize cultivars, not the soils or the quality of the water. And that is in another range of knowledge that we are not addressing with this database.
We had several questions about the cost of the application, also in the chat. As I mentioned before, all these tools are free to use. They will be available at the end of March when the project ends. And we also had more questions about, will I be able to receive the slides and the presentation? Yes, you will receive the slides and the presentation, and also the recording of the presentation. And you will be informed by email the moment the tools become available. So just to reiterate on that point, because some people had not heard it. Can this app be connected with their weather station information for more accuracy? So at the moment, no. I don't know if this could be doable, but that is not within the scope of this project. It does not require any registration or subscription. It's absolutely free to use. You will not have to register on the platform. You can use it as much as you want without giving out any of your personal information. So that's also a plus. So this was resolved, and I think that this was the last question that we had. So I will give the floor to Yorgos if he wants to conclude this meeting. And thank you very much for your attention. Thank once again to the European Commission for making this project possible. And thank you so much to our wonderful team for all the job that they have done, and all the results that have been achieved have been also thanks to them. So a big shout out to them. Thank you very much.
Okay, Alicia. So from my part also, thanks for your job, and to all the team and all the Gen4Olive and the audience today. I hope that it will be useful for everybody, and we are happy for it. And in a couple of days, we will try to share the presentation and the video recording. And hopefully in the maximum will be the end of March if we finish before the website in terms of finalizing all the details and launch it in the website. We will share with the participants by email the link. Okay.
Yeah, thank you to the audience. And also, once the database will be public, we also will be very grateful to have the feedback of the users, because I mean, we try to do it the best we could. And thank you to La Sapienza, to Dorjan, Alicia, Professor Luigi Mancini for it. But of course, everything is susceptible to be improved. Then once everyone starts using these applications and the database, we will be also very grateful if you can send your feedback, because I mean, in the future, we will be happy to improve it. Then thank you very much, Alicia, for your great presentation, and the audience for being there during this webinar. Thank you.
Okay, Giorgio, if you wanted to add something in Greek, I understood, because we have a big Greek audience.
Okay, yeah, just a few words in a very short message. Χαιρετώ τους συμμετέχοντες από την Ελλάδα. Βλέπω ότι έχει τεράστια συμμετοχή και ενδιαφέρον από την Ελλάδα. Πολύ σύντομα, για κάποιους που μπορεί να δυσκολεύονται με τα αγγλικά, είναι ότι το έργο, το GEN4OLIVE έκανε ένα όραμα που είχαμε εδώ και δεκαετίες, για όλες τις ποικιλίες να μπορεί κάποιος να βρει μαζεμένη την πληροφορία, αντοχές σε θερμοκρασία, σε έλλειψη νερού, σε ασθένειες, να μπορεί να τα βρει όλα μαζεμένα, και τα χαρακτηριστικά και του καρπού και του λαδιού κτλ. Αυτό είναι ένα εργαλείο πολύ χρήσιμο για όλους, και επίσης οι εφαρμογές που λέμε για αναγνώριση της ποικιλίας και της ασθένειας είναι δωρεάν για όλους. Σύντομα θα είναι ανοιχτά τα συστήματα αυτά για όλο τον κόσμο, δωρεάν, γιατί είναι από ευρωπαϊκό πρόγραμμα, και πιστεύω ότι θα βοηθήσουν πολύ τους παραγωγούς, και φυσικά μπορούν να βελτιώνονται και συνεχώς, αλλά είναι δωρεάν εργαλεία που θα είναι χρήσιμα για όλους τους παραγωγούς. Το Ινστιτούτο Ελιάς και Υποτροπικών στα Χανιά είναι ο φορέας που συμμετέχει στο έργο και μπορείτε να απευθύνεστε στο Ινστιτούτο για ό,τι χρειάζεστε πληροφορία, διευκρίνηση ή βοήθεια. Σας χαιρετώ εγώ και καλή συνέχεια για το ελληνικό κομμάτι. Okay, thank you, Christopher. That was all for the Greek part.
Thanks a lot, Giorgio. We have already the translation done in Greek. So as we say, we will share everything.
Okay. Yes, just to add that everything will be available also in the Greek language in the platform and the tools. I don't know if we mentioned it already. We will help in translating the material and have it in the
Yes,
Greek.
Alicia mentioned it in the beginning, yeah.
Okay, thank you.
Perfect.
Thank you.
So have a good day to everybody, and thanks for being here.
Bye-bye.
Thank you so much for
Bye-bye.
joining.
Have a nice day.
Have a nice
Bye-bye.
day, everyone.